All right, babies, you're going to be so excited because this is our last video in 4.1. I know it's taken us forever. All right, so we need to define a logarithmic function. Now that we have started talking about exponential functions, we need to define a logarithmic function. Why, Miss Griggs? Because the logarithmic function is the inverse, you guessed it, of an exponential function. Well, Ms. Griggs, why does it need its own separate name? Why can't we just call it the inverse of the exponential function? Because it has the form, just stay with me here, y equals log base b of x. All right, so I want you to think about it this way. Logarithms give us a way to deal with the inverses of exponential functions. Why do we need a way to deal with them? Well, I want you to think about something. Remember what an inverse is, all right? If I've got a function, let's say y equals 2x, okay, the inverse of that is when I switch the x and y and then solve for the y, right? That's what an inverse looks like. Well, I want you to think about what an exponential function looks like. If I have y, let's say, to the y equals a to the x. Well, the inverse of that is going to be x equals a to the y. Well, we can't deal with that mathematically because everything we do in functions is going to be in the form of y equals. Well, once y is up there in that exponential position, we're in trouble. We need a way to deal with that. We need a way to pull it out of there. So the way we deal with it is having a logarithmic form versus an exponential form. So let me show you what I'm talking about. If I have an exponential form, b to the y equals x, I need a way to deal with that so that I don't change the value, but that I have a way to actually solve it or to find the value, meaning y equals. So I can write this in log form, log base b of x equals y. And then it's in a solvable form because y equals now, which is exactly what we want. So this is the same as this. The values are the same. It's just that now in logarithmic form, I can deal with it. So let's keep in mind several things. The base is b, base b, just like that. All right. We also, though, have what we call natural logs. Okay, they're just in a different base. Natural logs are in a base of e. We know what e is because we already found out that e is the Euler number. So what would this look like? Well, the log form would look like this. Natural log x equals y. When I see that it's a natural log, I'm automatically assuming that it is in a base of e because it is a natural log. All right, so that means that the exponential form of this would look like this. It would be base e to the y equals x. All right, so let's do some practice because that's the best way to learn how to do this. So I have given you these examples here. These are all in log form. I need to be able to write them in exponential form because I need to be able to go back and forth to do some of these problems. All right, the base is in 32, so I'm going to be in a base of 32, and that is going to be raised to the 2/5 power equals the 4. All right? Yes, you're going to do all of them exactly like that. And you can check it out because 32, basically what this means is 32, the 5th root of 32 squared. I know, right? Well, the 5th root of 32 is 2. 2 squared is 4. It's right. Trust me. I hope y'all are loving your math right now. Okay, So log base 6, so 6 to the negative 2 equals 1 over 36. Yes, it does. 6 to the negative 2 means 1 over 36. Awesome. Okay, log base 8 to the 2/3 equals 4. The cubed root of 8 is 2. 2 squared is 4. Yeah, baby. They're true statements. That's all I'm showing you. All right, what if we have to go the other way? So these are all in exponential form here, and I want to write them in logarithmic form. So I'm just practicing writing them back and forth. Well, I've got base 5 to the 3, so I'm going to write log base 5, and it's going to be log base 5 of 125 equals 3. Same thing here. Log base 4 of 1 over 64 equals negative 3. Log base 81 of 3 equals 1 over 4. Magical. Yes, we are going to use these for other things, but for now, you just need to understand how to write things from exponential to logarithmic and back the other way. All right.